let's take a look at the different type of reactions. So identifying the types of chemical reactions helps chemists to predict what will happen when substances interact. Most chemical reactions can be classified as one of 5 major types of reactions. So we're going to look at the types of reactions, and then you should get used to the different types of reactions well enough that you can predict the result of a reaction if I just give you the reactants. You should be able to say, these are the reactants, it's this type of reaction, what are the products going to be? All right, so the first kind that you need to know is the synthesis kind. The synthesis is 2 or more substances combined to form one substance. So A plus B gives you AB combined. Could be more, A plus B plus C. 3 reactants give you one chemical formula A, B, and C. But it's more than one thing coming together to form one thing. So here's an example of one. We got magnesium plus oxygen gives us magnesium oxide. To balance it, 2 magnesiums, 1 oxygen gives us 2 magnesium oxides, right? It's always O2 with oxygen because oxygen is diatomic. So that's synthesis, coming together. The opposite of synthesis is decomposition. So one substance reacts to form 2 or more substances. So this time we start off with A and B, and it breaks apart to become A and B. Or we could have A, B, and C, breaking apart to become A and B and C. That's decomposition. So water can be decomposed by electrolysis, electricity. You take water, you run electricity through it. You need a little salt in the water too, and you can get your hydrogen and your oxygen. Okay, so that's decomposition, the opposite of synthesis. So we have synthesis, then we have decomposition. Now we're going to identify the following as either synthesis or decomposition. So our first one, we have 2 KClO3, it's a solid, gives us 2 KCl, solid, plus 3 O2s, a gas. We have 1 reactant becoming 2 products. That's going to be a decomposition. So look at our second one. We have CaCO3. That's calcium carbonate. And that's a solid. Breaks apart to give us CaO, a solid, and CO2, a gas. Now notice it doesn't have to break apart evenly. It just needs to be one thing being broken apart into 2 or more things. It doesn't have to be a precise breaking apart, but just a breaking apart. This is also decomposition. If you look at the third one, you should be writing down the answer for the third one already. We have 2 carbons, they're solid, plus O2, diatomic, oxygen, it's a gas, to give us 2 COs, carbon monoxide, a gas. 2 things coming together to form one product is a synthesis reaction. So synthesis and decomposition are kind of opposite reactions. Synthesis, 2 or more things becoming one. Decomposition, 1 thing becoming 2 or more. Let's look at the single displacement or single replacement reaction. So one element trades places with another element in a compound. So we have a lone guy here. He's by himself. We got a happy couple right here, but they're not that happy because A butts in and he says, B, take a hike, I'm taking the girl, and he takes the girl. So B got kicked out of the relationship and now A is in. So this lone chemical replaced one member of the couple. So here we have aluminum plus iron 3 oxide gives us aluminum oxide and iron. You can see here the aluminum and the iron swap spots. So you can see now the aluminum's with the oxygen and the iron's alone. That's a single displacement. So single displacements where you have a lone guy out here and a couple. The lone guy breaks up the couple, goes with one of them, and we've got a new alone guy. That's single displacement. Double displacement or double replacement. This is when anions and cations of two different molecules switch places, forming two entirely different compounds. So this is a whole big double swap. So A is with B and C is with D. The first two guys swap, and this is how we usually do it. We do the first two guys swap. So the A is now with the D, and the C is now with the B. Now in these ones, because it's ionic, the A can never go with the C, and the B can never go with the D. Okay, so A plus B and C plus D give us AD plus CB. Okay, so here's our example of a double replacement. We've got PbNO3, so Pb is a cation, NO3 is an anion, K is a cation, and I is an anion. Notice how the Pb and the K swap spots. The K used to be with the I, but now the Pb is with the I. The K used to be with the I, but now the K goes with the NO3. So the K is now with the NO3. We had a double displacement happen here. Okay, so this guy and this guy are usually reactions with ionic compounds in them. Usually, these reactions have ionic compounds in them. An acid-base reaction is a special type of double displacement. Acid-base reaction is a special type of double displacement. So we take an acid, we add to that acid a base. And we usually get a salt and a water. The salt is just an ionic compound. That's all salts are, ionic compounds. So acid plus base equals salt and water. It's an acid-base reaction. When we get into acids and bases a little more, we'll look a little bit more at this. But an acid-base reaction is a special type of double displacement reactions. All right, the fifth type of reaction that we get are combustion reactions. Combustion reactions, or oxidation reactions, oxygen combines with another compound to form water and carbon dioxide. These reactions release heat, that is, they are exothermic. There are two types. There's complete combustion, which occurs in the presence of sufficient oxygen, and we get products of CO2 and H2O. There's incomplete combustion, occurs when there's not enough oxygen, and our products could be CO2, H2O, CO, C. We could get a whole bunch of different products. Depends how it's incomplete. So combustion reactions, we're going to deal with hydrocarbons. This is a hydrocarbon because it's made up primarily of hydrogen and carbon. This is propane. And we get oxygen. To it, we take propane, we add oxygen, give it a little kickstart with a spark, and we get a combustion reaction. And if there's enough oxygen, it's going to produce carbon dioxide and water. Now let's balance this, because we should always balance every reaction we get. 3 C's, 1 C, so we need a 3 there. 8 H's, 2 H's. So we need a 4 there. Now we have the correct number of C's, the correct number of H's, O's last. We got 6, we got 4, that's 10. So we need a 5 there. So it's 1, 5, 3, 4. All right. Now an incomplete reaction, instead of CO2, we might get CO plus H2O. So this is carbon monoxide coming out of it, and an incomplete reaction, this carbon monoxide could be bad. This carbon monoxide can kill you. So now if we're going to balance this guy's a little different to balance than this one up here. 3 C's, let's do 3 C's here. H's, same thing, 4. Now O's, now look here, we've got 3 O's and 4 O's. We've got 7 O's. So we put 3.5 in here for O2. So 1, 3.5, 3, and 4. But we can't do 3.5. We can only do whole numbers. So this would be 2 C3H8s plus 7 O2s plus gives us 6 carbon monoxides and 8 H2Os. So there you go. There's complete combustion where you only get CO2 and H2O. Incomplete combustion where you get something else. So remember the 5 types of chemical reactions. Synthesis, 2 things coming together to form one thing. Decomposition, 1 thing breaking apart to form many things. Single replacement, where a lone guy switches spots in a couple. Double displacement, where 2 couples swap partners. Acid-base reaction, which is just a special type of double displacement reaction. And a combustion reaction, which when we do combustion reaction, a hydrocarbon plus oxygen gives us carbon dioxide and water. All right, so thank you for watching about the types of reactions.